Good afternoon. Today we are going to do practice of question on measurement and angles. So now you see first question. Find the degree measure. Question is find the degree measure corresponding to the following radian measure. Following radian method. First, 11 by 16. Second, -4. Third, 5 pi by 13. 5 pi by 3. And fourth is 7 pi by 6. So now your objective is to change these angles given in radian measure into degree measure. So first is 11 by 16 radian. This is 11 by 16 radian. And now you can write, first we change this in pi radian. So 11 into pi upon 16 into pi. Now substitute pi equal to 22 by 7 only in denominator. So this can be written as 11 pi upon 16 into 22 by 7, that is equals to 77 pi upon 16 into 22. 11 2 is 22, 11 7 is 77, that is equal to 7 pi by 32. So now you see your 11 by 16 radian is converted into 7 pi by 32 radian. So that is in pi radian. So in order to change this pi radian into degree, you have to multiply the given pi radian by 180 upon pi. So this is equal to 7 pi upon 32 multiplied by 180 upon pi. This much degree. So you cancel this. 4 8 to 32, 4 4 to 16, 4 5 to 20, and this is equal to 7 into 45 by 8 degree, that is equal to 315 by 8 degree. So now you have to change 315 by 8 degree in degree, minute and second. So you divide 315 by 8. 8 3 is 24. 7 5, 8 9 is 72, your remainder is 3, 79 degree. Now 3 degree is equal to 3 into 60 minute, that is 180 minute. So again you divide 180 by 8, 8 to the 16, 20, again 8 to the 16, 8 to the 16, 4. So this is 22 minutes. Now 4 minutes. Now 4 minutes. 4 minute equals to 4 into 60 second, that is equals to 240 second. So again you divide 240 by 8. 8 3 is 24, 0, 30 second. So 315 by 8 degree is equals to, now 315 by 8 degree is equals to 39 degree, 22 minute and 30 second. So this is the degree measure of radian measure 11 by 16. Now come to second part. -4 radian. Your second part is -4 radian, that is equals to -4 multiplied by pi upon pi. Again you substitute pi equal to 22 by 7 in denominator. That is -4 pi upon 22 into 7. 2 2 is 4, 11. That is equals to -14 pi by 11. In order to change pi radian into degree, you have to multiply it by 180 upon pi, this much degree. So that is pi and pi will be cancelled. Now this is equal to minus 2680 by 11 degree. Minus 2680 180 multiplied by 14, 180 multiplied by 14, 2520. This is 2520. This is 2520 by 11 degree. So in this way, you divide 2520 by 11. 11 to the 22, 3 2, 11 to the 22, 100, 11 9 is 99. That is 1. 229 degree. Now 1 degree is equal to 60 minutes. You divide 60 minutes by 11. That is 11 5 is 55. Your remainder is 5 minutes. 5 minutes is equals to 5 into 60 second. That is 300 second. You divide 300 by 11. 11 to the 22, 80, 11 7 ja 77. Your remainder is 3 seconds. You leave that. This is second. So in this way, minus 2520 by 11 degree is equals to minus 229 degree, then 5 minutes and 17 seconds approximately. This is not exactly, this is the approximate value of given radian into degree measure. So similarly you can do your third and fourth part, and in third and fourth part there is no any change, so you have to do it directly. How will you do third? That is 5 pi by 3 is equals to 5 pi by 3 multiplied by 180 upon pi. Pi and pi will be cancelled. 60, that is equals to 300. So this is equal to 300. In the same way you can do your fourth part, do yourself. Now second question. Your question is, a wheel makes 360 revolution in 1 minute. In 1 minute, how many, through how many radians, through how many radians does it turn? Does it turn in 1 second? Now you see that your question is that it is asked how many turns that wheel makes in 1 second. That wheel is making 360 revolution in 1 minute. Your 1 minute is time. Your 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. So wheel is describing 360 revolution in 1 minute. It means since in 60 seconds a wheel can make 360 revolution. Therefore, in 1 second, by using unitary method, you can find how many revolution it makes in 1 second. How many revolution that wheel can make in 1 second, equal to 360 divided by 60, that is equal to 6 revolution. Now, angle described in 1 revolution is equal to 360 degree. 360 degree are 2 pi radian. In 1 revolution is 2 pi radian. Therefore, angle described in 6 revolution, that is equal to 6 into 2 pi, that is equal to 12 pi radian. That is the answer of this question. This is the answer, you remember that. Now, next question. Find the degree measure of the angle. Find the degree measure of the angle subtended at the center at the subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter. So now you see that in this question, find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter. Now you see that this is the circle. I have taken 2 points A and B on its circumference. Its center is O. You join A to O, O to B. So in this way, your arc length AB is equal to 22 centimeter and radius equal to 100 centimeter. That is equals to OA equals to OB. Now, and let angle AOB is equal to theta in radian. So in this case, by the formula, theta equals to L by R. Your theta is defined as L by R. Your L is 22, this is L, this is R, 22 by 100, this is 11 by 50. So 11 by 50 can be written as, this is multiplied by pi, divided by pi, 11 pi upon 50 into 22 by 7. That is equals to 11 pi into 7 upon 50 into 22. So 11 2 is 22. It is equal to 7 pi by 100. Now you see that in order to change this pi radian into degree, you have to multiply it by 180 upon pi. Your pi and pi will be cancelled. Your 0 and 0 will be cancelled. 2 5 is 10. 2 9 is 18. That is equal to 9 7 is 63. 9 7 is 63. 63 divided by 5. This much degree. Now you change this into degree, minute and second. How will you change that? 63 divided by 5. 5 1 is 5. 1 3 5 2 is 10. That is 3 degree. And here 12 degree. Now 3 degree is equal to 3 into 3 into 60 minute. That is equal to 180 minute. You divide 180 minute by 5. 5 3 is 15. 3 0. 5 6 is 30. Remainder 0 this minute. So in this way you can write 63 by 5 degree is equal to 12 degree and 36 minute. That is the answer of this question. Now next question. In a two circle, if in two circle arcs of same length subtend of angle 60 degree and 75 degree at the center, find the ratio of their radii. Find the ratio of their radii. So now you remember that here two different circle means their centers and radius both are different. So now in this case your center is O, or center of this is O dash, here your arc length AB subtends an angle theta 1, and here arc CD subtends an angle theta 2. Arc AB subtends angle AOB is equal to theta 1. Arc CD subtends angle COD equal to theta 2. These angles are given to you. This is 60 degree and this is 75 degree. So in this way, as you know that L1 equal to R1 theta 1 and L2 equal to R2 theta 2. Here you have given that we have given that L2 is equal to R2 theta 2. This is 1, this is 2. We have given that L1 equals to L2. Your arc length are equal. Your arc length AB and CD are equal. L1 and L2 are equal. Therefore, R1 theta 1 equals to R2 theta 2. So, R1 by R2 ratio of their radii is equals to theta 2 by theta 1. And in this way, you can find R1 by R2 is equals to your theta 2 is 75 degree divided by 60 degree, that is the ratio, therefore degree unit is cancelled. It is simply 75 by 60, 15 5 is 75, 15 4 is 60, that is 5:4. So R1 is to R2 equal to 5:4. The ratio of their radii are 5:4. Now, second topic is trigonometric function. Now I am going to start trigonometric function. You are familiar with that. You already know trigonometric function as a trigonometric ratio in class 10th. So, what are the syllabus of this area? I am writing that. First is your syllabus. Definition of trigonometric function with the help of a unit circle. Unit circle means a circle whose radius is 1 unit. Next is truth of sin square x plus cos square x is equal to 1 for all x. That is sine of trigonometric function. Sine of trigonometric function. Sine of trigonometric function. Domain and range. Domain and range of trigonometric function. and their graphs. And their graphs. Trigonometric identities. These are the syllabus. So I am taking the first one. Definition of trigonometric function with the help of a unit circle. I am going to do this. Now, definition of trigonometric function. Definition of trigonometric function with the help of a unit circle. Help of a unit circle. See that. Now for this, you draw a circle with center O and radius OA equal to 1 unit. Draw a circle with center O and radius OA equal to 1 unit. Take a point PAB on its circumference. This is the point PAB. So you join OP, your OA equal to OP. OA and OP are equals. If we draw a perpendicular from P to OA, then this M is the foot of perpendicular, then OM is taken as A and PM is equals to B. Let angle AOP is equal to X. I have taken this angle as X. So in this case, and angle OMP is equal to 90 degree. Therefore, in right angle triangle OMP, right angle at M, apply Pythagoras theorem at M. Apply Pythagoras theorem. So in this case, your OM square plus MP square is equal to OP square. OA equal to OP equal to 1 unit. This is your assumption. So in this case, you can write your OM is A, PM is B. So A square plus B square is equal to 1 square. That is 1. This is your result number 1. So now you see in triangle OMP, sin x, this is A and this is B, your sin x is equals to PM upon OP, sin x is equals to PM is B upon 1, that is equal to B, that is the y coordinate of point P. Apply in the same triangle, apply cos x, that is equals to OM upon OP, that is equals to A upon 1, that is the x coordinate of point P. So in this way, your value of A is cos x and value of B is sin x. Substitute in 1. This is your result number 1. You see, this is the result number 1. Substitute in 1. You get cos square x plus sin square x, that is equals to 1. This is the truth of the result cos square x plus sin square x, and it is explained by using a unit circle. So now you have to see the definition of trigonometric function by using unit circle. So you have seen here sin x and cos x. In the same way, you can define tan x, cot x, sec x, cosec x from this triangle. So that is your tan x is B upon A. Your cot x is A upon B. When you want to explain that, your cot x is A upon B. Your tan x is B upon A. Your sec x is 1 upon A. Your cosec x is 1 upon B. And when you go for cosec square x is equal to 1 plus cot square x. So you substitute the value of cot x, that is equal to 1 plus A square by B square, that is B square plus A square by 1, your B square, and your B square plus A square is equal to 1 in 1 by 1. This is 1, so it is 1 by B square. So your cosec square x is 1 by B square, hence cosec x is 1 by B. You can verify that by the formula also. So now these are the explanation of trigonometric function by using unit circle. Then we have to write down the coordinate of the point. First of all, I want to say you, when the moving line describe quarter of the circumference, then angle described by the moving line is pi by 2. Here you see the explanation. So this is your x and y axis, xo, x dash, yo, y dash. When you draw a circle by using radius 1 centimeter, so you see when you draw a circle of unit radius, your OA is equal to 1 unit, that is A dash, this is B, and this is B dash. If OA is 1, so it is 1 0. When OB, length of OB is 1, that is same as OB dash, and this is same as OA dash. So this is 1 0, your A dash is minus 1 0, and B is 0 1, and B dash is 0 minus 1. So here angle described is pi by 2, your this angle is pi by 2, and your this total angle is pi, and here 3 pi by 2, and here 2 pi. So in this way, by using this concept, you can write for quadrant angles. Quadrant angles. So you see that this is the first quadrant, your angle is 0 to pi by 2. For second quadrant, your angle is pi, and similarly for third, this is 3 pi by 2. Your total angle described is 3 pi by 2. In this way, we have the following result. We have the following result. First, cos 0 degree is 1 and sin 0 is 0. Then second, cos pi by 2 is 0 and sin pi by 2 is 1. Third, your cos pi is minus 1 and sin pi is 0. Your value of sin pi is 0. Then fourth, your cos 3 pi by 2 is 0 and sin 3 pi by 2 is minus 1. Fifth, your cos 2 pi is 1 and sin 2 pi is 0. So these are the values of sin and cos at quadrant angles. Now consequently we can write the following results. You may see sin of 2n pi plus x is equal to sin x for all n belongs to z, and cos of 2n pi plus x is equal to cos x for all n belongs to z. So from this is 1 and this is 2. From 1, you see your 1, your sin x is 0. When your sin x is 0, when x is 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. So at these points, this implies that sin x vanishes. Sin x vanishes means its value is 0, it has no value. Sin x vanishes when x is integral multiple of pi. Integral multiple of pi. Multiple of pi. So now come to cos x. From 2, your cos x equal to 0 when x is equal to plus minus pi by 2, plus minus 3 pi by 2, plus minus 5 pi by 2, and so on. At these values of x, your cos x is 0. This implies that cos x vanishes. Then its value is 0 when x is an odd integral multiple of pi by 2. Now we come to this point, sin x is 0, x belongs to n, x equal to n pi, where n is an integer. X is equal to, sin x is 0, x is equal to n pi, n belongs to z. Cos x is 0 when x is equal to 2n plus 1 into pi by 2, n belongs to z. That is the final result for this. This is the final result. This is final result. You remember that. This is your final result. So now you know that now define other trigonometric function in terms of sine and cosine. Now definition of other trigonometric function in terms of sine and cosine function. Now define other trigonometric function in terms of sine and cosine function. So now you see, first of all, I am taking cosec x. Cosec x is equal to 1 upon sine x, and this function is not defined when x is an integral multiple of pi. So for this, x is not equal to n pi. Your cosec x is defined only when x is not equal to n pi. Your cosec x is defined as 1 upon sine x, and cosec x is defined only when x is not equal to n pi. Then sec x equal to 1 upon cos x, and this is defined when x is not equal to 2n plus 1 into pi by 2. N belongs to z and n belongs to z. Now tan x is equals to sin x by cos x is defined when x is not equal to 2n plus 1 into pi by 2 and n belongs to z. Then cot x, that is equal to cos x by sin x, is defined when x is not equal to n pi, n belongs to z. You have already seen sin x and cos x. Definition of sin x and cos x we have seen. That too, and these fours. There are 6 trigonometric functions. In this way we have defined all the trigonometric function by using a unit circle. And some formulas you have done in your class 10. That formulas we are also using here. So just I am writing about that and you learn it. You know some formula. Sin square x plus cos square x is 1. From here, sin square x is 1 minus cos square x, and cos square x is 1 minus sin square x. This is one set. Then another is sec square x is equal to 1 plus tan square x. From here you can write sec square x minus tan square x is equal to 1. Sec square x minus 1 equal to tan square x. That is your same formula. And now another is cosec square x equal to 1 plus cot square x minus cot square x is 1 and cosec square x minus 1 equal to cot square x. This is another. Now, domain and range of trigonometric function. Now I am going to define the domain and range of the trigonometric function. Domain and range of the trigonometric function. Domain and range of the trigonometric function. Of the trigonometric function. First, domain and range of sin x. Domain and range of sin x. Domain is defined as all x's that x belongs to R. This is set of real number. Your domain of sin x is set of real number, and your range lies between minus 1 and 1, including minus 1 and 1. So it can also define in set builder form as all x's that x belongs to R, minus 1 is less than or equal to x is less than or equal to 1. This is the meaning of that. Now second, domain and range. Domain and range of cos x. So domain is equal to, this is defined as all x's that x belongs to R. Domain of cos x is also set of real number, and your range is equals to closed interval minus 1 and 1. Now third, your domain and range of tan x. Domain and range of tan x. Domain equals to, domain is defined as all x's that x belongs to R and x is not equals to 2n plus 1 into pi by 2, n belongs to z. This is your domain and range of tan x. Range equals to open interval minus infinity to infinity, that is R. This is the range. Now next one is domain of cot x. Fourth, domain and range of cot x. Domain is equals to, this is defined as all x such that x belongs to R and x is not equal to n pi, n belongs to z. This is the domain, and your range is also minus infinity to infinity. That is the set of real number. Now fifth, domain and range of sec x. Your domain is defined as all x such that x belongs to R and x is not equals to 2n plus 1 into pi by 2, n belongs to z sec x. This and range is equals to minus infinity to minus 1 union 1 to infinity. Minus 1 and 1 is included. Cos pi is minus 1. Cos 2 pi is 1. That is another domain and range of cosec x. Last, sixth, domain and range of cosec x. Your domain is defined as all x such that x belongs to R and x is not equal to n pi, n belongs to z. Your range is equals to minus infinity minus 1 union 1 to infinity. So these are the domain and range of trigonometric function. So now we comes to graph of the trigonometric function. Now the graph of trigonometric function. Graph of trigonometric function. In order to show the graph of any function, we need points that satisfy the graph. So by keeping this thing in our mind, we can draw the graph of any function. So I am taking y is equals to sin x. So you take different value of x. For different value of x, you find the value of y, and that x and y makes a point xy. You plot on the coordinate plane and you join them, and that will be the graph. So now you see. This is for sin x. This is x sin x. Your value of x is minus 4 pi, minus 7 pi by 2, minus 3 pi, minus 5 pi by 2, minus 2 pi minus 3 pi by 2, then minus pi by 2, 0, pi by 2, 3 pi by 2, then pi, pi 3 pi by 2, 2 pi, 5 pi by 2, then 3 pi, then 7 pi by 2, and then 4 pi. So I have taken the value of x from minus 4 pi to 4 pi, and their value of sine at this value of x, sine of minus 4 pi is 0, sine of minus 7 pi by 2 is 1, sine of minus 3 pi is again 0, sine of minus 5 pi by 2 is minus 1, this is minus 1, 0 and 0 minus 1, then sine minus 2 pi is 0, this is 1, this is again 0, sine of minus pi by 2 is minus 1, sine 0 is 0, sine pi by 2 is 1, sine pi is minus 1, zero and 0 minus 1, 0 and 0 minus 1, 0 1, sine pi is 0, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 0, sine 5 pi by 2 is 1, sine 3 pi is again 0, sine 7 pi by 2 is minus 1, and sine 4 pi is 0. So now you see its graph. This is since you have observed that your graph of sin x, means value of sin x varies between minus 1 and plus 1. This is x dash, this is y dash, your this is minus 1 and your this point shows plus 1. This is minus 1 and this is plus 1. Now you see, this point is minus pi by 2 and your this point is pi by 2. Then this is minus pi and this is pi. This is minus 3 pi by 2 and this is 3 pi by 2 and this is 2 pi and this is minus 2 pi and this is minus 3 pi by 2 and your minus 5 pi by 2. This point is minus 5 pi by 2 and then 5 pi by 2 and again this is 3 pi and this is minus 3 pi and this is 7 pi by 2, 2 pi, 4 pi, sorry, this is 4 pi and here minus 7 pi by 2 and minus 4 pi. So So now you see minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, etc. are the image point of pi by 2, pi 3 pi by 2, 2 pi under origin. These are the image point. So they are at equal distance from right and left. So in this, and its value lies between 1, minus 1 and plus 1. So when you start from minus 4 pi, minus sign of minus 4 pi is 0 and this is 1. Then 0, here minus 1. Then 0, then here 1. Then 0, then minus 1. This is minus 1. Sin pi by, then this is 0, sin pi by 2 is 1. Then sin pi is 0, sin 3 pi by 2 is minus 1. Sin 2 pi is 0, sin 5 pi by 2 is 1. Then sin 3 pi is 0, this is minus 1. Then this is 0. So in this way now you join them. You join them carefully. So this is the graph of sin x, and this graph is taken from minus 4 pi to 4 pi. This is the graph of sin x. So that's all for today, and I will do the graph of remaining trigonometric function tomorrow. Thank you.